All right, so our last section, section 6.2. This is our regression, and this is the meat of what everyone will be doing for their final projects. This is what will allow us to make predictions. So through a regression, we will come up with a regression formula that will allow us to make predictions. For example, if I have a regression formula for the size of a house and what it should sell for, I can plug my house in, my house's size, and it will predict how much it should sell for. So that's what regression allows us to do. So, definitions. A regression line is a straight line that mathematically summarizes the relationship between two variables. So this is what's going to happen with a regression. So in section 6.1, we had this scatter diagram with the income of someone and the number of Xbox games they owned. I just put some dots up here. Okay, so what a regression is going to do is this. It's going to take a straight line. It doesn't really do this, but it's easier to imagine what it's doing. And it's going to kind of flop it back and forth. And it's going to measure for each of these. It's going to kind of get an idea of the distance from the line to the individual points. And what it's going to do is it's going to stick a straight line through the center of the blob, basically. That's supposed to be straight. So it's going to draw a straight line through the center of this blob. This line minimizes the sum of the distances between the line and the dots. So it adds up all these distances. And it minimizes it. So if it was any place else, this sum would be larger. And technically, it's actually not it doesn't minimize the sum of the distances, it actually minimizes the sum of the squared distances. So it's sometimes called the line of least squares. So it's minimizing the sum of the squared distances. You don't really have to know that that's what it's doing to calculate this thing, but that's in essence what it is doing. So we are going to come up with, you're going to have a high school flashback here, we're going to come up with a formula that's in this format, y equals mx plus b. So through our calculations, we are going to calculate a formula that's in this format. M is the slope of the line. And what that means is, if I increase x by 1 unit, how much does y go up or down? That's what m is. So if m is negative, that means my line is going to be going down. As x goes up, y goes down. If my m is positive, as x goes up, y goes up. B is my y-intercept, which means what value does y have when x is 0? So if x is 0, what value does y have at that point? So what's going to happen is, we're going to calculate m. Let's say we get 10 when we calculate m. We're going to calculate b. Let's say we get 5. And then we're going to write out the formula. Y equals 10x plus 5. So we're going to solve for m and for b and then plug it into our formula. Okay, so I just went over most of what's on here, but let's read through it again anyway. So m is the slope that measures the angle of the regression line. The y-intercept, which is b, is the value of y when x equals 0, or the point at which the regression line crosses the y-axis. So, as I said, the main function of regression is to make predictions. However, the regression equation should only be used if there is a statistical correlation. I cannot tell you how many times a company has hired me to do consulting. They've dragged me in. They said, oh, we use such and such program to make a regression equation and it's not working. It's not predicting anything accurately. So then I always say, really? Well, what's the correlation between the two values? Well, I don't know. did someone actually figure out if there's a statistical correlation between the two of them? I don't know. So then we check it, and sure enough, there's no relationship. So obviously, if there's no relationship, the equation that we get from our regression is going to be worthless, right? How about the number of pens I have in my bag compared to my shoe size? Obviously, one has nothing to do with the other, right? But I could still calculate a regression equation for that. It's going to be meaningless because obviously it doesn't make a difference how many pens I have compared to my shoe size. So there has to be a statistical correlation. If there isn't, the regression equation should not be used for predicting. Instead, our best estimate of the second variable is simply its mean, the mean of the sample. So let's talk about some common errors with regression before we even learn how to do it. Do not use the regression equation to make predictions if there is no statistical correlation. We just covered that one. So if there's no correlation, the regression is worthless, and there's no reason to do it. Number two, stay within the scope of the gathered data when using the regression. So I do my correlation, and I calculate my regression line for this. And then Bill Gates calls me in, and he says, let's see how accurate your regression line is. Before we do that, let's say the person, 120,000 was the income of the person that had the highest income that I got on the phone that would talk to me. So Bill Gates, so this is 0 to 128,000, 120,000. Bill Gates says, tell me how many Xbox games I own. Okay, first of all, Bill Gates' salary is what? Fisher's campus, right? On the scale of things. So could I plug that salary in and solve for this? Yes. But chances are it probably wouldn't work. Because how do we know what happens to my scatter diagram beyond this point? It could do this. Right? I mean, think about it. So what are some of the popular, let's say, a lot of times people race cars on their Xboxes. If you made $10 million a year, would you sit down in front of a television set and drive a fake pixelated Ferrari on the screen? Or would you go out and buy a real one and drive that around? I would drive the real one. Would you sit down and play Call of Duty on your Xbox? Or would you go to that town in New Mexico that's an abandoned ghost town where they have all the buildings and they have all these plywood pop-up things, and they give you full machine guns, and you walk around and you blow these things away with your real machine guns? I would probably do that instead of playing Call of Duty. Would you have a flight simulator where you could fly this cute little Cessna on the screen, or would you go out and buy a Learjet and fly that around? I would probably buy the Learjet and fly that around. So chances are up above, say, a couple $1 million a year, you're probably not going to be playing the Xbox too much. So we don't know what happens outside of the range of our data. So that's why we never go beyond the scope of the data that we've collected. You should never use old data. So let's think about this. Since we're talking about video games. Think about video game systems. Most of you are not old enough, but back when I was about 10, 12 years old, the first video game system came out. It was a box, and it had two controllers that had knobs on it. And it had one game, and it was built into the system, and it had a line that went up and down on one side of the screen, a line that went up and down on the other side of the screen, and a ball bounced back and forth. It was called Pong. It was very expensive, and it was seriously, I had one, and every single person that I lived in the middle of nowhere in a small, very small farming community in Wayne County, and literally every single kid in the entire school district visited my house to see this thing, because that's how state-of-the-art it was. And it was really quite amazing because the lines were very bright. you played it for like, I don't know, half an hour, and then you get bored out of your mind, but it still was cool. I would sit there and just make the thing go up and down. We didn't have much back then along the lines of video games. So, fine, that came and went. The next major development, I remember one day, it was a birthday, and my father comes home and he's got this new game system, and he's got a big tube that came with it. It's a big, huge, long tube. And inside of it, you pull this piece of plastic out and you stick it onto your television set. Because there used to be all this static electricity on TV. So you plop this thing on, and my favorite one was a big picture of a haunted house. And behind it, there was a little light that lit up. And your job was to get your little light, because the color was all in the plastic that was on it, from the entrance to the haunted house, which you went in for some stupid reason and the door got locked, to the attic to get out the window. And while you were doing that, these blinky dots would chase you, which were supposed to be bats. It was very scary. So that happened. Finally, the Atari came out, and you had this stick with this big red button, and you could move it like this, and it had games that you could actually buy and plug into the top, like Asteroids and Centipede and Space Invaders and all that. And so that was the first fairly widely available game system. So think about it. If I collected data back then for people's salary and the number of Atari games they owned, even if I adjusted for inflation, it wouldn't work. And the reason for this is, back when game systems first came out, it was a completely different group of people that would buy them. Mostly, exclusively, they were adults that bought them for children. Adults really never played video games back then. The other thing is it really wasn't based on your income, whether or not you owned a game system. It was really based on your proximity or what you did for a living and how connected you were to things. Like, a lot of people didn't even know they existed when they first came out. Like Pong, most people didn't even know that that existed, that there was even an option to own such a thing. The people that did were the people that were in, technology circles. We didn't have the internet back then. It's not like something came up on Facebook and then within a day the whole world knew about it, right? It took time back in those days. So the people that owned these Ataris, it didn't really matter based on income. It was more based on their availability to get these things because they happened to work by a store that sold them, or they knew someone that owned one, and so on, as opposed to nowadays. Nowadays, think about the people who own it. Warcraft is very popular, right? The average age of the person that plays Warcraft is 38 years old. I mean, back when I was a kid and had an Atari, you never saw an adult play games. I introduced my father a long time ago to one of the very first-person shooters called Doom. And I said, Dad, you got to try to play this. I think I was in college back then. And he's like, I'm not playing video games, that's for kids. I said, you walk around with a shotgun and you shoot things. You'll love it. You got to give it a try. Nope. I said, well, I'm going to put it on your computer, try it sometime, and just don't tell me you tried it. So next thing you know, he loves it. So here's this guy that's, I don't know how old, playing this game. And he thought it was the coolest thing ever. So he was hooked. Right? This is how bad it was back then. If a new game came out that he wanted, he wouldn't go buy it because he was afraid someone would see him in the store to buy the game. He would send me in to get it for him. But nowadays, everyone has them. He has an Xbox 360 system. He plays Call of Duty all the time, and he's 70 years old. So it's a very common thing for older people to be playing these now.
Like the headphones.